We begin the chapter Static Electricity. In static electricity, we study about stationary charges. Charges exist in nature in two kinds, in two forms. We call them as positive charge and negative charge. We know in an atom there are protons, neutrons, electrons. Protons carry positive charge and electrons carry negative charge. Neutrons have no charge. The amount of charge carried by a proton is same as the amount of charge carried by an electron, but the kinds of charges are opposite. Proton carries positive charge and electron carries negative charge. So the atom as a whole doesn't exhibit the nature of charges. The nature of a charge will be exhibited only when the charges are separated. So electrically, atom is neutral. If we can remove one of the electrons from the orbits of the atom, then the atom will be charged. It becomes a charged atom. So whenever electrons are removed, atom behaves as a positively charged body. We know that when a glass rod is rubbed with a silk cloth, electrons will be transferred from glass rod to silk cloth. This is the process of separation of electrons from glass rod. The atoms in the glass rod, they lose electrons and they will be transferred to the silk cloth atoms. So glass rod becomes positively charged and silk cloth negatively charged. The body which loses electrons is positively charged, and the body which gains electrons, which acquires electrons, is negatively charged. So glass rod is positively charged and silk cloth is negatively charged. The effect of charges were discovered long before the structure of the atom is known. Conservation of charge and quantization of charge. We know that charge exists in nature and it can neither be created nor be destroyed. So charge may be transferred from one body to the other body. The total charge is same in the universe. It can neither be created nor be destroyed. Generally, we denote the fundamental unit of charge by the small letter E. We denote the unit of charge by small e. The value of this small e, fundamental unit of charge, can be taken as 1.6 into 10 to the power of minus 19 coulombs. Fundamental value of charge is taken as 1.6 into 10 to the power of minus 19 coulombs. We can take the charge of proton as plus E and that of electron as minus E. On rubbing a glass rod with a silk cloth, if n electrons are transferred from glass rod to the silk cloth, if the number of electrons transferred from glass to silk is say n, then the charge on the glass rod is plus Ne. Plus Ne is the charge on glass rod and minus Ne is the charge on silk cloth. We cannot get a fraction of E. That means E by 2, E by 3, E by 4, etc. A fraction of E is not available. The minimum amount of charge that is available is E, and its multiple is only is available. So 2E, 3E, 4E, like this the charge is available. Hence we say this fact is termed as quantization. We know that positive and negative charges attract each other. Like charges repel each other, unlike charges attract each other. So positive charge and positive charge repel each other, negative charge and negative charge repel each other, and positive charge attracts a negative charge. The force F between two charges is directly proportional to the product of their charges and is inversely proportional to the square of the distance between the two charges. If Q1 and Q2 charges are separated by a distance r, then F is proportional to Q1 Q2 and F is proportional to 1 by r square. If we use d instead of r, F will be proportional to 1 by d square. So combining these two, we can write F is proportional to Q1 Q2 divided by d square. F is proportional to Q1 Q2 by d square. We can replace this proportionality by a constant k and write the relation as F is equal to k into Q1 Q2 by d square. This force acts along the line joining the centers of the charges. Coulomb's inverse square law can be stated as the force of attraction or repulsion between two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them and acts along the line joining the two charges. This is the statement of Coulomb's inverse square law. We have already derived the relation between the forces as F is equal to k Q1 Q2 by d square. But in SI system, we use a constant 1 by 4 pi epsilon naught. So the relation for the force in SI system should be taken as F is equal to 1 by 4 pi epsilon naught Q1 Q2 by d square. If there are several charges Q1, Q2, Q3, etc. in a plane, and these charges, they are nearby a charge Q, each one of them will apply a force on the charge Q. And the resultant force experienced by the charge Q is the vector sum of the forces acting on it. So it can be written as F bar is equal to F1 bar plus F2 bar plus F3 bar plus F4 bar, where F1 bar is the force applied by the charge Q1, F2 bar is the force applied by the charge Q2, F3 bar is the force applied by the charge Q3, and F4 bar is the charge applied by Q4. So F1 bar is equal to 1 by 4 pi epsilon naught Q1 by d1 square. F1 bar is equal to 1 by 4 pi epsilon naught Q1 by d1 square. And F2 bar is equal to 1 by 4 pi epsilon naught Q2 by d2 square. F3 bar is equal to 1 by 4 pi epsilon naught Q3 by d3 square. And F4 bar is equal to 1 by 4 pi epsilon naught Q4 by d4 square. These are the values of F1 bar, F2 bar, F3 bar and F4 bar. While doing this addition, this is a vector addition. So we follow the principles of vector addition for finding the resultant force F bar. Dielectric constant. Dielectric constant. It is a property of the medium. It is equal to the ratio of the force in air to the force in the medium for the same separation and for the same charges. It is equal to the ratio of the force between two charges in air to the force between the same two charges in a medium. So Fa by Fm. Fa indicates the force in air, Fm indicates the force in the medium for the same charges and for the same distance. We have already used a proportionality constant in the relation for force. F is equal to k into Q1 Q2 by d square. That constant k is taken as 1 by 4 pi epsilon naught in SI system. and its value 1 by 4 pi epsilon naught value is 9 into 10 to the power of 9, and units Newton meter square per Coulomb square. And epsilon naught is termed as permittivity of free space. Epsilon naught is termed as permittivity of free space. For a medium, we use this constant as 1 by 4 pi epsilon. For a medium, it is used as 1 by 4 pi epsilon, and we call this epsilon as the permittivity of the medium. This permittivity of the medium can be expressed in terms of the permittivity of free space as epsilon is equal to epsilon naught into epsilon r, where epsilon r is termed as the relative permittivity or the dielectric constant of the medium. Relative permittivity or dielectric constant of the medium. By using the values of 1 by 4 pi epsilon and 1 by 4 pi epsilon naught in the relation for force in a medium and in vacuum, we get the ratio of the forces as epsilon by epsilon naught, that will be equal to epsilon r, which is dielectric constant. Coulomb. Coulomb is the unit of charge. It can be defined in the following manner. The unit of charge can be defined from the relation for force between two charges. The relation between two charges in air or vacuum is given as F is equal to 1 by 4 pi epsilon naught Q1 Q2 by d square. If we take Q1 is equal to 1, Q2 is equal to 1, and d is equal to 1, then F becomes equal to 1 by 4 pi epsilon naught. We know that this value is 9 into 10 to the power of 9. So we can define Coulomb in the SI system as Coulomb is that charge which, when kept at a distance of 1 meter from a similar charge in air or in vacuum, and is repelled by a force of 9 into 10 to the power of 9 newtons, since in SI system distance d is equal to 1 meter. So Coulomb can be defined as it is that charge which, when kept at a distance of 1 meter from a similar charge in air or in vacuum, and is repelled by a force of 9 into 10 to the power of 9 newtons. Like this we can define Coulomb. When charges are created, it gets distributed on some substances, and it will not get distributed, and it will remain where it is created on some other substances, and in some substances it travels due to impurities. In substances like glass, the charges created will remain where they are created. Such substances are known as insulators. Insulators. In insulators, there will be no distribution of charge. In some substances like germanium and silicon, due to impurities, doping of impurities, the flow of charges takes place. Such substances are known as semiconductors. Charges given to metallic substances like copper, brass, iron, etc., it gets distributed over its surface. Such substances are called conductors. In conductors, the charge flows freely. When the charge is distributed, we measure the charge with a quantity known as charge density. We can define it as the charge per unit area. The charge that is situated over unit area is called as charge density. If a charge Q is distributed over an area A, then the charge density is defined as sigma is equal to Q by A. Charge density is indicated with sigma, and it is given by Q by A. Suppose on a sphere of radius r, if a charge Q is situated, generally if it is a metallic sphere, it gets distributed over its surface. So the charge density on the surface of the metallic sphere is Q by 4 pi r square Q is the total charge given to the substance, the sphere, and R is the radius of that sphere. If there is a pointed end, if we attach a pin to the sphere, at pointed ends, the charge distribution will be very high. The density will be very high. So when the charge density is very high, a strong electric field will be created and the charge will be discharged into the air. Earth. This is the name given to a connection. When we use electrical devices, sometimes charge will be created on these devices. If that charge is not removed, then it gives shock. Hence, to remove the charges created on the surfaces of some electrical devices, we use this earth. It is actually a connection to the earth. Earth connection will be given. It is a separate connection which is created to the home. It is symbolized as shown at the top with 3 lines. Then, if a body is having positive charge and if it is connected to the earth, a body having positive charge, the right rectangle indicates with pluses, indicates the body charged with positive charge. When this is earth connected, then electrons from earth will travel through that connection and the body will be neutralized. The charge will be neutralized. We say the charge has flown to the earth. The green one on the left is a body with a negative charge. The dots indicate electrons. So it will be excess of electrons. When it is earth connected, then these electrons will flow to the earth and thereby it becomes a neutral body, uncharged body. So the charge will be removed like this. But we say the charge has flown from the body to the earth. Like this, the action takes place whenever a body is earth connected. Charging a body by induction. Charging a body by induction. Consider a metallic rod placed on an insulated stand. Charging a body by induction. Charging a body by induction. Consider a metallic rod placed on an insulated stand. A metallic rod is laid horizontally on an insulated stand. Let us bring a positively charged glass rod nearby this metallic rod. When the glass rod is brought near this rod, glass rod is having positive charge. Initially, the electrons and positive charges at the left, they get separated and the electrons will flow to the right end. This is induction. The electrons from the left end, they move to the right end and electrons and positive charges, they get separated at the left end. So the left end becomes positively charged and the right end becomes negatively charged. At this stage, if the right end is earth connected, the electrons will flow to the earth. Electrons will flow to the earth. Now, if we remove the earth connection and remove the glass rod to a distant place, then the positive charge created on this rod, it gets distributed. Here, when the negative charge, the electrons move to the right end, then an attraction takes place between the glass rod and the metallic rod. So, first it induces charge, that is creates positive and negative charges, and then it attracts. So the glass rod attracts this metallic rod after separating the charges. That we name it as induction precedes attraction. This action is termed as induction precedes attraction. Lightning conductors. Lightning conductors. Clouds floating in air acquire charges due to friction between two layers of clouds. Due to the friction between two layers of clouds, they acquire charges. A negatively charged cloud, while passing over a conducting surface, induces positive charge. A negatively charged cloud, while passing over a conducting surface, like a wet tree or wet man or wet building, it induces positive charge. And thereby an attraction takes place between the positive charge and negative charge. So the electrons, the excess of negative charge on the clouds will be attracted by the induced positive charge, and thereby electrons will flow through the air. Air acts as the medium for the flow of charges. So these electrons will flow through the air. While flowing through the air, they establish a current. A current is established due to the flow of electrons to the earth, to the conducting body. Due to the burning of the air, the current, it produces heat and sometimes light. So due to burning of this air, heat and light are produced. Heat, light and sound are produced. That light is known as lightning. It is lightning. And the current passes through an object like tree, man or building, which gets damaged, which gets burned. While passing through the air, vibrations are set in air. Sudden vibrations, loud vibrations are produced. Those vibrations, those sounds are known as thunder. Thunder is the sounds produced due to the flow of charges in air. And the light produced is known as lightning. The intense light produced is known as lightning, and the sound produced is known as thunder. Lightning appears earlier because the speed of light is very high compared to the speed of sound. Though both of them are produced simultaneously, the speed of light is more than the speed of sound. Hence, first we see lightning and then the thunder. The damage due to these currents that flow to the conducting bodies is known as the effect of this lightning effect. By erecting rods, vertical copper rods on the top of the buildings, high buildings, the charge can be transferred to the earth by earth connection of these rods. So rods vertically erected and which are earth connected are used at the top of the buildings to remove the charges from the clouds. Such rods are known as lightning conductors. So lightning conductors prevents this thunder effect. Properties of charges and charged bodies. Properties of charges and charged bodies. Like charges repel each other and unlike charges attract each other. Like charges repel each other and unlike charges attract each other. The force between two charges acts along the line joining the centers of the two charges. The force is present even if the charges are in vacuum or in a medium. Bodies can be charged by friction, by conduction and by induction. The charge gets distributed on a conductor but resides where it is created on an insulating material body. The charge density is very high at pointed ends or at sharp points, or when the radius of curvature is very small. The tip of the lightning conductor is sharp so that the induced charge becomes discharged into the air due to high charge density. The conducting lightning conductor end should be very sharp so that there is no charge residing on it. Induced charge should go into the air as soon as it is created. This will be done when the charge density is very high. So it should be sharp. Charge flows on the outer surface of a conducting body. When charge flows in a conductor like a copper rod, it flows on the outer surface of the copper rod. On stationary charges, magnetic fields have no effect, but magnetic fields do apply force when the charges are in motion. Moving charges can be affected by magnetic fields but not stationary charges. By traveling themselves, they do not undergo any changes. Charges do not undergo any changes due to their motion. The force between two charges depends on the magnitude of the charges, the distance between the charges, and the medium in which they are situated. These three are the parameters on which the force depends. The electrostatic force is about 10 to the power of 35 times stronger than gravitational force. The charged bodies may have mass. Because of mass, they will experience gravitational force. But this gravitational force is very, very weak compared to electrostatic force. So while studying the electrostatic force, we neglect the effect of gravitational force since they are almost negligible compared to electrostatic forces. When a charged body is brought near an uncharged conductor, when a charged body is placed near an uncharged conductor, an equal amount of opposite charge is induced at the near surface. Here, equal amount, same quantity of charge will be created, but of opposite kind at the near surface, and an equal amount of like charge is created at the far end. A positive charge induces negative charge, and a negative charge induces positive charge at the near end. An uncharged conductor is attracted by a charged body due to induction. An uncharged conductor is attracted by a charged body due to induction. First, the opposite charge is induced and then attraction takes place. This is termed as induction precedes attraction.